In this video, I'll discuss a couple of JEE Main PYQs from the topic thermal physics. Given two temperature scales, how to relate the values between them. For example, value of temperature in Celsius scale and Fahrenheit scale, how do you relate them? First, let me go to the basics. Suppose I have two variables, x and y. How to define the relationship between them? One way to define the relationship is when x takes a value x1, y will take a value y1. When x takes a value x2, y will take value y2, x3, y3, and so on. So if I make a table like this, where when x is known, the value of y is known, then the function is defined. Another way of describing this function is, suppose we plot on the horizontal axis value of x, on the vertical axis value of y, and there is a curve like this which describes the relationship between these two variables. So here, if value of x is given, say x1, we can find the corresponding value of y, y1. Some other value of x, say x2, and the corresponding value of y, we can find out. So this is another way of describing the relationship between two variables. So similarly, if you have two temperature scales, say T1 and T2, we can plot those values on the two axes, and the relationship between them is known if this curve is known. The simplest curve we can have is a straight line. So given temperature according to two different temperature scales, so if here first scale the temperature value is T1, according to the second scale the temperature of the body is say T2, and the relationship between them, the simplest relation we can have is a straight line. So if the equation of this line is known, then the relationship between the two temperature scales is known. So finding the relationship between two temperature scales is same as finding the equation of this line. For a given line, we can know the equation if the slope of the line is known, and if one point to which the line passes is known. This is a point lying on this line. So this point, say it's x1, comma y1, and there's an arbitrary point here of coordinates x comma y. The property of the line is slope between any 2 points is same. So this slope between these 2 points is delta y by delta x of these 2 points. So this delta y is y minus y1. The coordinate of the point is y, that means from here to here it is y, and coordinate of this point is y1, y coordinate, so from here to here it's y1. So from here to here it is y minus y1. Similarly, delta x from here to here is x minus x1. So the slope of this line is y minus y1 divided by x minus x1, because slope is given as delta y by delta x between any 2 points. That's equal to the slope given m. So given slope at a point on the line, this is the equation of the line. There's another way we can describe the equation of the line. Instead of giving the slope, say we are given a second point, x2 comma y2. So the slope of this line according to these 2 points is y minus y1 by x minus x1. Similarly, if I take these 2 points, then the slope will be between these 2 points. Delta y is this delta y is y2 minus y1, and between these 2 points, delta x is from here to here, that is x2 minus x1. So slope of this line I can write using these 2 points. That will be y2 minus y1 by x2 minus x1. So these two should be equal because the property of the line is slope between any 2 points is same. So given 2 points, the equation of the line is given like this. So with this understanding, we can solve the question. This is the first question. The graph between two temperature scales P and Q is shown in the figure. Between upper fixed point and lower fixed point, there are 150 equal divisions on scale P and 100 divisions on scale Q. The relationship for conversion between the two scales is given by 4 options are given. So basically, to find the equation of this line. The equation of this line is the relationship between these two variables on the y-axis and x-axis, which is the temperature according to scale P and temperature according to scale Q. You can pause and attempt this question. This is a straightforward question. So there are 2 points here. This is the lower fixed point and the upper fixed point. The lower fixed point x coordinate is this origin, so 0, and y coordinate is 30 because this is 180. That means from here to here it's 180 and this much is 150. So from here to here it should be 30. So this is the lower fixed point and upper fixed point is x is 100 and y is 180. So 2 points on this line are known, x1, y1, x2, y2. And also the slope of the line is known, delta y by delta x, which is 150 by so equation of the line we can find by multiple ways. You can use this slope and first point, or this slope and the second point, or I can use these 2 points. So let me try to get the equation using slope and the first point. So on the y-axis we have P scale. So slope is temperature according to P scale minus the first point, y is 30, divided by the x variable is TQ, and the first point x value is 0. So this is the slope of the line between the points TP, TQ and the first point. That should equal to 150 by 100. So we have to see whether this thing matches any of the options given. So TP minus 30 by 150 R. So if I bring this 150 down, it will become TP minus 30 by 150 equal to TQ by 100. So it matches with option 2. So option 2 is the correct answer. Now that's the correct answer. That's what I explained here. So equation of a curve between two variables x and y is the relation between the two variables. Sure. Here is the straight line. So equation of this line, given the slope at a point is y minus y1 equal to m into x minus x1. This is result from analytical geometry. So the 2 points here, the lower fixed point is 0, 30 and upper fixed point is 100, 180. That's from the graph that's given in the question. This is the lower fixed point 0, 30 versus 0, 0. So this x is 0 and y here is from here to here it's 180 and from here to here it's 150. It's given here. So this from here to here it should be 30. So y coordinate of the lower point is 0, 30. And second point is x is 100 and y is 180. So second point is 100, 180. So 2 points on the line are given and the slope is also known. It's 150 by 100. 150 by 100 between those 2 points. So equation of line I can give you multiple ways. So one way is to use the first point and the slope known. So first point is y is 30, so TP minus 30, TP P is on the y axis equal to the slope 150 by 100 into x minus x1 which is TQ minus 0. So this if we rewrite we get like this, matches to option 2. So correct option is option 2. Let's move to the next question. A 40 thermometer reads 5 degrees Celsius in melting ice and 95 degrees Celsius in steam. The correct temperature on absolute scale will be dash Kelvin when the 40 thermometer reads 41 degrees Celsius. So in melting ice, the correct temperature is 0, but the 40 thermometer reads 5. And in steam, the correct temperature is 100, but the 40 thermometer reads 95. So when the 40 thermometer reads 41, what is the correct temperature? Again, here we are relating two temperature scales. One is the correct temperature and other is the 40 thermometer. You can pause and run this question. So this is similar to the previous question. So one temperature scale is the 40 temperature, let me call it TF. Another temperature is the correct temperature TC. So 40 temperature is reading 5 in melting ice when the correct temperature is 0. So this is 1 point 5, 0 on this relationship. And the second point is 95 on the 40 thermometer. And the correct, this thing will be 100 because it is steam. Steam temperature is 100. So 95. So this is the second point of the relation. So point of this point is 95, 100. The simplification we can have between the two temperature scales is a straight line. So join these 2 points and we can extend them. So if you know the equation of this line, then the relationship between the two temperature scales is known. So to get this equation, since 2 points are known, let me assume a third point here. X is TF, arbitrary point, and y coordinate is say TC. So slope of this line using these 2 points is TC minus 0 divided by delta x, it's TF minus 5 equal to slope between these 2 points. Y2 minus y1 is 100 divided by x2 minus x1 is 90. So this is the relation between the two temperature scales. It's actually a straight line relation because it's first order in both x and y variables. X variable is TF Y variable is Tc. So when faulty thermometer is 41, so when Tf equal to 41, we can get the value of Tc using this one. Tc will be equal to this 10 by 9 into Tf is 41. Okay, so sorry, Tf is 41. 41 minus 5 is 36. So 9 4s are 36. So this value is 40 degrees Celsius because both these readings are in Celsius, both 40 and correct temperature. So, but you have to find the answer in Kelvin. So this is equal to 40 plus 273. To convert to Kelvin, you have to add 273 to Celsius degree. So this value is 313 Kelvin. So that is the correct answer. So this is what I explained here. So the temperature according to two thermometers, 40 thermometer and the correct thermometer, there is some relation between them, and the simplest relation we can have is a straight line. And the 2 points are, one is the ice point, 5 according to the 40 temperature, but the correct temperature is 0. And the 40 reading for steam is 95, but the correct reading is 100. So 2 points are low. So this is the relation we have to use for finding the equation. So using that we get Tc, it's on the y-axis, minus the first point y, 0, equal to the slope that you can use these 2 points. So delta y is 100, delta x is 90. So 100 by 90 into first point Tf minus the first point x, which is 5. So Tf minus 5. So this is the equation between the two temperature scales. So when Tf equal to 41, you can put the value of 41 for Tf, and the correct temperature value will be 40 in Celsius degree. To convert to Kelvin, you have to add 273, so that will get 330.